Good day, students, and welcome back to my series. I'm still working a paper that was written by our grade 12 learners of 2022. Today, I'm going to look at question 6 and question 7 and also question 8, the Euclidean part of it, but I'm going to end at 8.3, and question 9 and 10 are still part of Euclidean, but I'm going to do them on a separate video. Let's check question 6, that is primarily trig functions. You can also check the other videos which I made on this particular paper. Let's check. What are they saying here? They are saying in the diagram below, the graphs of f and g, where f is given by the tangent of x and g is given by a 2 sine of 2x, are drawn for the interval that is in between negative 180 degrees and 180 degrees. The points A and B are, A and B are points of intersection of F and G. Let's check. The point A is somewhere there, and then the point B is somewhere there as well. So they give you the coordinates of A, which is primarily 60, and K. Now they ask you to find, to write down the period of G. So I'm going to write question 6 just right here. I'm just going to write question 6. Let's see how far we can go with that. Question 6. So I'm going to write a 6.1. Write down the period of G. I want you guys to check something. The graph of G, the period is now affected by this number that is 2 right here. But each period, primarily it is 360 degrees. We are going to divide it by this number that is here, and that is 2. So I'm going to say this is divided by 2, and it's going to give me 180 degrees. That 2 basically affects the period. And these 2, the other 2 outside, it affects your maximum value or your amplitude. So let me just go to 6.2 and save time. And then 6.2, there are 2 situations there. There is 6.2.1. Write down, calculate the value of K. So if we look at K, K belongs into 2 graphs, and that is F and G. So I'm going to say that F at X is equals to tangent of X, and then say that at point A, it's a point A, it is 60 degrees, and K. Check something. If I take this point and put it just right here, it's going to give me the K. Remember that K is the Y value of that point. So I'm going to put it here because this point passes through F and G. Therefore, this is going to be K is equals to a tangent of that angle, which is 60 degrees. And this tells me that this is going to be a square root of 3. That is the value of K. This is how far you can go with it. But because this point, this point A passes through F and G, you could have said that, let me just write or. You can say that G of X, which is given by 2 sine of 2x, which you can just write at point A. So point A is 60 and K. So, but K is still your Y even at G. Let's plug it. This is going to be K is equals to 2. And then a sine of 2 times 60 degrees. And then if you do it nicely, you will still get K as a square root of 3. So this is the other way of getting that value of K. It was a straightforward problem. So this tells you that the point A, it's 60 and K. Now let's go to the next question. That is 6.2.2. They say calculate the coordinates of B. Check something at point B. This is point B here. And I want you to check something with point B and point A. Point A and point B are basically the reflection of each other, And check something at A and B. That is where the 2 graphs meet, I'm going to do it in this way. Just check something here. Let me just make it this way. And just, I think the blue will do. Check something. That means that from this point to this one, X is what? X is 60. degrees. And this also means that if now I'm to move this line here to here, I'm going to get that point there. And that point is primarily going to give me something like, I'm moving with 60 degrees to the right. So that means it's going to be 120. But the value of k, it's going to be negative square root of 3 because it's really below the x-axis. And these points are primarily a reflection of each other. Now, check something. If I go to the left now, the left of it, it's basically somewhere there. So this tells me that, let me just make it that way. Check. This means that at this point, that is negative 60 degrees and what? And negative square root of 3. Check something here also. If I move to point B, that is 60 degrees from this point to that point B. It means at point B, if I add 60 to the left, that means I'm going to get a negative 120. That means B is negative 120, and the y value there of k, that remains a positive of root 3. So this tells me that point B is negative 120 degrees and the square root of 3. And by the way, these are one mark question. That means you don't have to really stress a lot. Let's check. They are going to mark you for that and also mark you for that if you use this method and also if you use that method. So for this point B, they are going to give you 1 mark for that. That is your analysis. I want you guys to check something on this particular question. Let me just go to the next question. They say that determine write down the range of 2g of x. So this is 6.3. Write down the range of this one. So this is 2 multiplied by g of x. So this is the same as 2 multiplied by that g. Our g is still, it's primarily, let me just do it in that way. Just check something. Your g here, that is 2. This is 2 sine of 2x. This means that you're going to get 4 of sine of 4x. So we're looking for the range of this graph. So you can see that, my goodness, what is happening there? Okay, I don't know what really happened there. I think it's here. Sorry about that magic. Check something here, guys. You will see that this is where you are now. You want to find the range of this graph. So you are going to get the minimum and the maximum of this graph. So this graph really has a maximum at this value there, that is positive 4, and a minimum of a negative 4. So this means that this is 2 marks. So you are going to say that your y should be bigger or equals to negative 4, but should be less than or positive 4. That is your range. For some of you who may have put it differently, let me just say, you can say that the range is y element of, you include those points because this graph is defined everywhere. It's not like the tangent. So this is going to be your range of this particular graph, this new graph of 2g of x. So now, yeah, that's how you really go about it. And then 6.4, and then 6.4, what are they saying here? 6.4, they are saying that for which values of x will this expression, this inequality, that is g of x plus 5 degrees minus f of x plus 5 degrees less than or equal to 0 in the interval. So this time around you are playing at this region in the interval, negative 90 and 0. Check something, guys. They are giving you some inequality thing there. That is a g of x plus 5 degrees minus f of x plus 5 degrees is less or equal to 0. What you can do here, you can just play some algebra to say that this is g of x plus 5 degrees, which is less or equals to f of x plus 5 degrees. We are looking for the values of x for which g of x is less, g of x plus 5 degrees is less than this expression. I want you guys to see something now. What is happening to g primarily is that we are shifting it to the left by 5 degrees, also f. So how about if before we shift it, we find, how many marks this thing? This is 2 marks. How about if we find g of x, where, less than or equals to f at x. Let's find these points where this guy is less or equals to f. So we are going to check where they are equal first thing first, but we are now looking at from negative 90 to negative 90 to 90 degrees to 0, I mean to say. So we are basically going to be focusing our region here. Where are these two guys equal? They are equal at this point, which we know is negative 60 and negative root 3, and also at the origin. This is where the graphs are equal. And check something. At the same time, this is where g is less than f at x, or f is above g. This is, remember that this is uf, is the tangent one, and then this one is the other one. So this is where the tangent graph is above, this means above g. So in that region, check something in that region, eh? Let me just write f at x here. I want you guys to see something at this space. So that is in between negative 60 and 0. That's where we are now. So x is in between, this should be negative 60 degrees for x there at this point. I don't know why it's doing this at that point there, at this particular point. So this should be less or equals to 0. So now for this inequality, now we want to move the points. We want to move these points to the left. That means we are going to get a negative 60 degrees minus 5 less or equals to x less or equals to 0 minus 5 degrees. Therefore, this will boil down to negative 65 degrees less or equals to, you're going to get a negative 5 in there. For those of you who love interval notation, you can say that x it's in between. You can put it in this way. That is negative 65 degrees and negative 5. That is still allowed there. This is how far I'll go with this question. Okay? Well, it was a bit tricky, but this is how you go about it. This is 2 marks, so you may be able to read them correctly. It's really easy. It's 2 marks, so I was just trying to explain this unnecessary step here. There's no marks for them, but this is how you normally you arrive to the answer. You have to play some algebra in there, but the answer is really this one, or you can leave your answer in the inequality notation, which is that one. Now, if you look at the next question, what are they saying? That is 6.5. They said determine the value of p for which this equation, that is sine x multiplied by cos x is equals to p, will have exactly 2 real roots in the interval. That is negative 180 to 180 degrees. So what I will do is I will say I want the value of p for which sine x multiplied by a cos x is equals to a p, for which this will have exactly two real roots in that interval. So this will have two real roots at what? At its turning point, and that is your maximum and your minimum. So the best thing to do will be to convert this into a single trig ratio. How do you do that? We can apply algebra again to say that 1 over 2 multiplied by 2, this is really something like 1. So you are definitely going to get a sine x there and a cos x. That is really going to be equals to p. Check something. This is 1. That means this equation is the same as this one. So now we are going to say to ourselves, this is 1 over 2 into 2, and then a sine of x multiplied by a cos x is equals to p. Check something, This is still the same as the given problem. But now the beautiful part is this is now going to be a single trig ratio, and that is 1 over 2. What do you get here? You get a double angle of sine, That is a sine 2x is equals to p. So we are looking for the value of p for which this will really have two real roots. So this will mean that it's going to occur at its maximum and minimum. So what is the minimum of this one? That is really going to be p is equals to positive 1 over 2, which is the maximum, or p is going to be negative 1 over 2. This is how you're going to get the value of p. But if you want to really take it far, you can say that, let me just write or. I'm going to take it from here. And say, think about it. I'm looking for a single trig ratio. That means that I'm going to multiply throughout by 2. This is already a single trig ratio, but you can still play and look at what you were having in there. So this is going to be sine of 2x is equals to 2p if you multiply throughout by p. Check something. Sine 2x you seem to be having just right here. So what you can do is, or maybe before you even go further, what you can do is you can say what is the maximum and the minimum of this graph. So that is a plus or minus 1, this graph. If you try to sketch it, this graph is really going to behave something like those snakes, you know them. So it's going to have a minimum and a maximum at plus or minus 1. So this means that you're going to have a 2p, which is this 2p here, which is equals to plus or minus 1. Therefore, you divide everything by 2. You get p is equals to plus or minus 1 over 2, which is what we got there. Now, check something. I want to show you something. You can say or. I want to take it also from here and play with it, just to show you that there are myriad of ways to do these things. Check. Like I said, you're going to multiply everything by 2. So you're going to get the sine of 2x is equals to positive 2p. Now, you look at the graph which was given here. That was 2. This was 2 sine 2x. So that means you just need 2 here. All right? You just need 2 for that one. So I'm going to play with it such that it really gives me back the given polynomial. So to do that, I'm going to multiply the whole of this equation by 2. I'm going to say multiply 2 both sides. So this becomes 2. Sine of 2x is equals to, if you multiply this by 2, you are going to get a 4p. Check something, what is the maximum and the minimum of this graph? We said that is really going to give us a positive 2 and negative 2. So this means that 4p, this value here, that is 4p is equals to plus or minus 2. So therefore, you can divide throughout by 4. By 4 years. You get p is equals to If you divide both sides by 4, so it's plus or minus 1 over 2. So the value of P is indeed plus minus, it's plus or minus 1 over 2. This is how I will work it out. One of the option has to be in there. So, I'm in marks. This was 3 marks. This was 3 marks. So it's really easy. Must be able to convert it. So they want the mark there and the mark there. And to be able to really play this type of algebra and have the P as that format, that should give you 3 marks. And then for this one, of course, you'll have to arrive to that space. So that's how I'll go about it. Let's check the next question. I don't want to spend so much time in here. Question 7. Let's check what are they saying with question 7. They are saying that AB, what is AB? AB there, let me check AB. Okay, there is my AB. My AB is a vertical flagpole that is root 5p in meters. So this whole stuff is in meters long. AC and AD are 2 cables anchoring there, the flagpole. Okay, that is AD, that is AC, I mean to say, and AD. Okay. And they say that B, C, and D are in the same horizontal plane. This is the horizontal plane they are talking about. They give you the length of BD. BD is 2p, and they give you AB, that is root 5p. And they give you angle D, the whole of this angle here, that is 45 degrees. The whole of that angle, that is 45 degrees, okay. They say determine the length of AD in terms of P. Where is AD? They want this length here. So this length belongs to a bunch of triangles. So it belongs to a big triangle like that. It also belongs to this triangle just right here. Let me do it in this way. This belongs to this triangle. But this triangle, we are told that this is 90 degrees. This is 90 degrees. So we should be happy about that. Okay, let me just do this. Yeah, that is 90 degrees. So we should be happy. We can use, how do you find the angles there? I mean the sides in a right angle triangle. So this is a right angle triangle. You can use Pythagoras, you can use trig ratio, to find that length. I think the best way will be to use Pythagoras theorem, because I don't know this angle, I don't know the angle, so it's really going to be a tough one. The best way will be to use a Pythagoras theorem, because it's a right angle triangle. That is to say that AD squared should be equals to AB squared plus BD squared. AD is what you are looking for. That is AD squared is equals to AB. What is AB? AB is that vertical flagpole that was square root of 5, and P, you square that, and then BD, that was 2p, you have to square that. Therefore AD squared is equals to, that is 5p squared, and then plus 2p squared, so that is going to give me 4p squared. Therefore AD squared is equals to, that should suffice to add now to 9p squared. Therefore you are looking for the length, Therefore the length of AD should be, you can't say plus or minus because this is the length, so you must square, you must take the positive one. So if you square 9p squared, it's going to give you 3p. I hope you are fine with that. So you're going to get a 3p. This will really give us 3p. The next question, that is 2 marks. I don't know why they really think the marks will be to correct it, substitute correctly, and also get the answer. There is 2 marks, so the other works are really subsequential. Let's get this one 7.1. I didn't even number it. My goodness, I just like, you know what, this is not good, so I must number it properly. So let me number it properly. That is 7.1. We're now going to 7.2. What are they saying here? They are saying show that the length of CD, let me check CD quickly. This is the length of CD. We have to prove that that length is equals to that situation. But check something, huh? This is 5 marks, so it's a grade 11 work. You know, we can go back to 2D, but in this case, it has to be 3D because of that horizontal plane. So this is 3D. Check what you're going to do. You have the sides of, you now have the sides of AD. You found that to be 3P, right? And you have got the corresponding angle of the side, that is X. So let me just really do this. That is X. So the corresponding side of CD is primarily A, which you don't have, but you can get angle A because of you are given that this is really 45 degrees. So let's find angle A because it's something which we are short of right now. So angle A, I will say that I'll say C, angle AD there, this will be 180 degrees minus 45 degrees plus X. And I must give a reason for that. So my reasoning around this will be sum of angles of a triangle. I can just do that. And this will tell me that that angle CAD is primarily 180 minus 45. That is 135 degrees minus X if I remove the brackets correctly there. So now I have that angle. So, and I'm looking for that side of CD. So I'm going to say to myself that how about if I say that the CD that what I'm looking for divided by sine of that angle. We are now applying sine rule. Now, in a triangle ACD. So that is really CAD. It should be equals to AD divided by the sine of that angle there, that is angle C, the way I'm looking at it, that is AC and D. Now we just need to substitute everything here. What is CD? CD is what we're looking for, divided by sine of that angle A, that is 135. This is 135 degrees minus X. You close that, that is going to give you AD. What is AD? AD, you found that to be 3PA. You divide this stuff by sine of that angle C. We have X there. So from here, it's just an algebra that is required of us. So I'm going to cross multiply now and have sine X CD is equals to 3P multiplied by sine of 135 degrees minus X there. So I'm looking for CD. Therefore, CD is going to be equals to, let me have this situation here and put it here over sine X over sine X over sine X. Let me just do this. like that. So what I will do is, because I can see that this angle here, it's primarily a compound angle identity. This is now grade 12 situation. So I will say that therefore CD will be equals to 3P. And let me try by all means to expand that one. So that should give me sine of 135 degrees cos of x, and then a minus a cos of 135 degrees, and then a sine of x. I close that, and then I divide this by that stuff. I think that should be sine x. Check something, guys. This will really boil down to 3p. Let me just really do this. And then I have a sine of x here. And deal with that stuff inside. This stuff, if you look at sine 135, it's taking you back to a reduction of angles where 135 is basically the obtuse angle, and sine in that space is positive. So you're going to get a positive sine of 45 degrees and then a cos of x minus a cos of 135. In the obtuse space, cos is negative. So I'm going to get a negative cos of 45 degrees in there multiplied by a sine of x. And I close that stuff. And as a result, I'm going to get 3p. You divide this stuff. Check something here. This is a sine of x. Let me now deal with this stuff here inside. Sine 45 is primarily 1 over the square root of 2, or it's the same as root 2 over 2. Cos x, and then a positive, this is going to be positive because of those signs. So what do you get there? You get what now? You get a positive, you get the same stuff. Cos of 45 and sine of 45 is the same thing. But here you're going to write 1 over root 2. And then a sine of x there. You close it. And you can see that inside those brackets, there's something which is common. And that is 1 over root 2. So I'm going to get 3p there. And then take 1 over root 2 out. So this becomes 1 over root 2. And then multiply this by, I'm left with sine x plus cos x inside. So I can always do that. Let me just show that these are the things that I was coming along with a different color, which was that one. So this I must divide by sine x. Check something now. Now I'm going to say to myself that let me copy these things and show you something. Guys, this is proof, so you don't have to really bridge anything here. Now I'm going to multiply by, I need to rationalize 1 over root 2. So that is the same as root 2 multiplied by root 2. So check something here. If you do that, you will see that 1 over root 2 multiplied by root 2, you get 1 times 3p. So you primarily get 3p into sine x, and then plus cos x. You divide this by sine x times root 2. So that is going to be root 2 primarily, and then a sine of x. So this will really then give you CD, the length of CD. Therefore, the length of CD that you have proven, guys, that is CD. And let me just write, this is CD. This is how far you'll go about it. That is CD. That is 5 marks, so it's worth all types of of maths there. It's really worth it. Let me look at 7.3. We are almost done. 7.3, if it is further given that P, okay, so let me put it down. P is 10 and X is equals to 110 degrees. Calculate the area of a triangle ADC, that big triangle there. We want to find the area of it. So if you look at that area of that triangle, it's not a right angled triangle. So we are going to use the area rule to find that area. How do you do that? You say that the area of a triangle that is ACD, okay, that is ADC, but there's no difference. So the area of a triangle that is not a right angle triangle in 2D, with the area rule I mean to say, you're going to get 1 over 2 multiplied by the sides, 2 sides, and with each angle. In this case, the angle which I can use here is 45 degrees. And then their sides are, I think it's AD, which we found, and CD, which we have just found now. So this will mean that it's going to be AD multiplied by CD, which we have just found, multiplied by a sine of that angle. So that angle is primarily going to be angle D. Or you can say it's ADC. Let me just really put it in that way. Multiplied by ADC. So this would give me 1 over 2. This should be 1 over 2 multiplied by AD. What is AD? AD, we got that to be 3P, if my memory serves me very well. So that was AD. We got that to be 3P multiplied by CD. What is CD? Eh? So CD, this is really going to be, we just found it here. It's that situation. So I may really need to copy it. That is, let me in fact open this one because I see some brackets there. So this is going to be 3P into, that was a sine x plus cos x divided by the square root of 2 sine x. This was that situation. I have to multiply this by sine of D, that is 45 degrees. Sine of that angle D there, that is 45 degrees. Let's take it out now to say we have 1 over 2 multiplied by what I can do now is to say that this 1 over root 2, I can just bring it here to say that is 1 over root 2 multiplied by 3P times 3P. So that is primarily like 9. 3 times 3 is 9 multiplied by P squared, multiplied by P squared, and then multiply by, so let me just do this, multiply by sine of 110 degrees plus cos of 110 degrees divided by sine of 110 degrees. You close it. Now we're not done, eh? We need to multiply by the sine of this one. So sine 45 is primarily 1 over square root of 2, or you can say it's root 2 over 2. So I think from here we just need to type it, and not really waste so much time. No, I need to plug that value of P. I didn't plug it. It's fine. I can plug it now. So if I bring this half this side, because it's a number, it's going to be 9 divided by This is going to be 9 divided by, I think it's going to be 2. If you multiply these 2, it's going to be 1 over 2 times 1 over 2 times 9, so that is 4. And then times p is 100. P is, let me just really delete this and put it nicely. Times p squared, p it was 100, given 100, 10. I was saying that when you square, you get 100. And then multiply by this stuff here. When you multiply with this stuff there, let me close it. Well, you just need to type it in your calculator, and then let me also type it. So that is 9 times 100 divided by 4 multiplied by sine of 110 and then plus cos of 110. These are in degrees over sine of 110. Can close it, and I'm getting 143,1066973. So that is like 143,11. So the signs were really in meters. So you can say that this is m meter squared. This is for the area, remember that. So it should be having that unit. So this is how you really work it out. This is how you really go about it. That's how I'll really work it out myself. So this is really easy. Let's go to question 8. What are they saying there? Question 8, 8.1. In the diagram O is the center of the circle. Okay, so we have got a center there, that is O. And then M and P R. So that is a cyclic quad. Let me just do that. This is a cyclic quad. I'm told that that is a cyclic quad. Yeah, I'm really struggling to redraw it nicely, but let me draw it from P then to that point. Okay, I hope you guys will get what is happening there. So that is a cyclic quad. That is true, the cyclic quad. And then SN there, that is a diameter. At least we are told that this is a diameter of the circle. The chord MS, MS. Okay, that chord MS, and the radius, where's the radius? OR. Okay, that chord there are drawn. So they're basically trying to tell you that these are drawn, and this will be twice angle M. It's angle at center, it's twice angle at the circumference. Okay, so angle M2 is given as 64 degrees. Determine, given reasons, the size of the following angles. So they want angle P, they want this angle, but they told that M and P are it's a cyclic quad. So you can say that angle M2, can put a cap there, angle M2 plus angle P, that should give you 180 degrees. And you must give a reason for this one. This is opposite angles of a cyclic quad are supplementary. Therefore, P is going to be equals to 180 degrees minus 64 degrees. And this should really suffice to angle P. Let's see what we get for angle P. That is 180 minus 64. I'm getting 116 degrees. With that reason, okay, this is 8.1.1. And then we also have 8.1.2. This is really easy, guys. I hope you can see that. So this is 8 point, my goodness, we're back again. So let me just take this one out. And then we have 8.1 and then 8.1.2. Calculate angle M1. Okay, there it is. There we check M1. Let me use the proper color for that. We are looking for this angle M1. But if we check M1 and M2 are primarily at a 90 scale, so I'm going to say that angle M1 plus angle M2, that is equals to 90 degrees. And I must give a reason for this. And that is to say that these are angles, an angle in a semicircle, angle in a angle in a semicircle, or you can say that, let me just say it to you. You can say that, you can say this is angle subtended by a diameter. That you can do, you can give that as a reason. That these are angles subtended by a diameter. So this will mean that angle M1 will be 90 degrees. Let me put it nicely, 90 degrees minus angle M2, that is 64 degrees. Therefore, angle M1 will be 90 minus that. We just need to be sober here. That is 26 degrees. Well, we go to 8.1.3. Calculate angle O1. So how will you find angle O1? If you look at O1, that's why they said SM, the chord MMS, and the radius OR are drawn. So that is to say that that angle, this angle just right here, angle O1, check it, angle O1 is twice angle M1, you know, and that is to say that angle at center is twice angle at a circumference. Angle at center is twice angle at a circumference. Therefore, angle O1 will be twice M1. M1 we got 26 degrees. So this would give us O1 as, if you multiply that, it's going to give you 52 degrees with the reasons. So this is how far I'll go with question 8.1. Let's check question 8.2. What are they saying there? Question 8.2. I think I'm going to end here. The next video, I'm going to continue from question 9, going that side. They are saying that in the diagram, this diagram here, let me be seated properly here. In the diagram, triangle ABG, let me mark it, triangle ABG, this triangle here, that triangle which I've just marked is drawn. D and E are midpoints of AB and AG respectively. Okay, those are midpoints. And their sides are primarily equal. So the sides are in proportion primarily. Now, what is happening? They say that the AG, I see, AG and BG, okay, are produced to C and H respectively. That is correct. F is a point. F is a point. That point there, F is a point on BC such that this one is really parallel. Okay, so this one is parallel. These lines are parallel. That is a good thing. That is a very good thing. That means let's check what else are we given. Nothing. So that means if let me just put back my triangle. If this one and this one are parallel, it means their sides are in proportion. It's called the proportionality theorem. What are they saying? Give a reason why DE, okay, give a reason why DE is parallel to that one. This is because their sides are in proportion. That is to say that their sides are in proportion. So you can say that the reason here is because AD over B, I think it's DB, it should be equals to AE over EG. Or if you don't want to give this reason, I think the other alternative is to say that this is the converse. This is the converse of proportionality theorem. This is the converse of proportionality theorem. This is the converse of proportionality theorem. So you can give this reason, or you can just write that one. One of the two, I guess, should be really correct. But I think both of them are correct. Just pick one. So this was 8.2.1. So 8.2 should be there. And then 8.2.2, they say that if it is further given that FC, we are given that FC, let me use another marker now that is best appropriate to this particular thingy. I think let me use this one. They give you FC over, this is FC over BF over BF. That is 1 over 4. They give you that one. It means even this one is also 1 over 4. Their sides are in proportion because FG is parallel to CH. They give you DE, that is x minus 1, and GH is x plus 1. Calculate, giving reasons, the value of x. Yeah, this should be very easy. How do you then pen it down? Let's say that FC over BF over BF, this is what was given, is equals to BG over GH, that is equals to 1 over 4. So you can give a reason for this one. That is proportionality theorem. This is proportionality theorem, which is, you must name the lines which are parallel. That is FG is parallel to CH, is parallel to CH. So the other way to write this reason, it would be to say that the line parallel to one side of a triangle, Yeah, you can just write that the line parallel to one side of a triangle divides the two sides proportionally. So this means that BG over GH is equals to 1 over 4. Therefore, if you cross multiply, what are you going to get? I just took this one. What are you going to get now? You are going to get what now? Let's check. You're going to get GH. GH is equals to 4. I think this should be 4 BG. That should really give you 4 BG. Wait a bit. I don't want to make any mistakes. I don't want to commit mistake. That is, I think I should have said here. I think somewhere there. It should have been the other way around. I'm having FC, so this means I must have GH. I must have GH here over BG. It must really be in that order. It must be in that order. So it means here I'm going to have a GH over BG. And when I cross multiply now, what am I going to get? I'm going to get BG is equals to 4 and then GH. But check something, eh? What is GH? GH they gave you here as x plus 1. So you can say that BG in terms of x, this is really 4 into x plus 1. Therefore, BG is equals to 4x plus 4. This is the length of BG. So because we have proven that DE is parallel to BG, because their sides are in proportion, what we can adopt now, or what we can apply to this problem, is the midpoint theorem, which states that DE is equals to half BG. This is half BG. You give a reason. That is a midpoint theorem. This is a midpoint theorem, and you must write why it's the midpoint theorem. That is DE is parallel to BG. We have proven that the lines there DE are parallel. So what is DE? They gave you DE as 3x. They gave you DE as 3x minus 1. So you're going to put 3x minus 1 is equals to 1 over 2 BG. BG is that one. So I'm going to put 4x plus 4. And this will mean that I'm going to get a 3x minus 1 is equals to, this should give me a 2x and then a plus 2. As a result, I'm going to bring 2 this side. It become positive, it become negative. So 3x minus 2x, that is x is equals to, I take 1 that side, I'm definitely going to get a 3 as x. So my x is 3 on this problem. Let's mark it. Yeah, there's a lot of marks here. 6 marks. So I must be able to get that one, the BG, and also to mention that statement and the reasoning of it. So that is 3 marks. You go to your midpoint theorem, and you substitute it correctly, and to get the answer there, it should boil down to 6 marks. So this is how I will approach this particular paper on these questions. That is question 6 up until question 8. My next video will be question 9. Please guys, don't forget to subscribe to the channel